All right, here we have the AP Physics 1, problem 17. It's a kinetic strategy problem. So we're going to take a look at this one. All right, first here you have the algorithm for the problem. It's got all the steps needed to solve any kinematic problem. Things like identifying the system of particles slash solid objects. What are the objects? Drawing and explaining your motion maps. Describing the variables that we know and that we don't know, identifying correct equations, filling in those equations, and then describing the relationship between the appropriate variables, and then, if necessary, solve for any unknowns in the equation. And then down here we have the kinematics graphing mnemonic, because this equation or this question has to do with graphing. So we have the XVA slope area mnemonic. All right, so the equation, here it is. It states a lion is running at a constant speed toward a gazelle that is standing still, as shown in the top figure above. After several seconds, the gazelle notices the lion and accelerates directly toward him, hoping to pass the lion and force him to reverse direction. As the gazelle accelerates toward and past the lion changes direction and accelerates in pursuit of the gazelle. The lion and gazelle eventually each reach constant but different speeds, which the following sets of graphs shows a reasonable representation of the velocities of the lion and the gazelle as functions of time. So up here we have a little picture. It shows the lion chasing the gazelle. Gazelle accelerates with the lion turns around. The lion is chasing the gazelle on the bottom one. And it gives us 4 different choices. Each of them has a velocity time graph for the separate particles of the lion and the gazelle here. So to solve this problem, we start out with identifying our objects or particles. Those are the lion and the gazelle. And then we choose a direction to be positive. And we choose a direction to be positive, which I chose the right to be positive. All right, so in this first picture here, this all say in the equation that the gazelle is standing still, it has no velocity, therefore it has no acceleration. And then the lion has no acceleration, but then is running at a constant velocity towards the gazelle, intent to catch it. And then the second scenario here, the gazelle will see the lion. The gazelle then accelerates to the right, running towards the lion. Velocity is increasing, and then it'll pass the lion. The lion, noticing this, is still going in to the left, but is slowing down, and his acceleration is going to the right in an attempt to slow down, and then speed up and catch the gazelle. And the final one here, it says in the equation that are both running at constant speeds, except they're constant but not equal. So here we have one of the sets of lines for velocity a little bit longer than the other, symbolizing constant velocity but not the same for the lion and gazelle. Next, we have identifying our variables. We know acceleration, time, and velocity. We know the velocity and time because those are the graphs that we're working with, and then acceleration because if we look over here, we can find the acceleration by the slope of the velocity time graph. And then unknown, we don't know distance because that's not given to us, but it's unimportant for the velocity time graph and which graph demonstrates this problem. And then for number 4, we have the velocity time graph will show the changes in velocity of the animals during the scenario. So just saying how it'll all change in the graph to show the entire problem. All right, here we have the answer. We have A for the answer. And now let's see why A is the correct answer. So here's the problem, and then this is the A for the answer. A is the answer because for looking at the lion velocity time graph, we can see a constant negative velocity here, which would be the lion running at a constant speed towards the gazelle. Then we have a acceleration, which is going to zero and then past zero. So then that would symbolize the lion slowing down, speeding up, or turning around and speeding up towards the gazelle. And then you have a constant positive velocity, which would be the lion chasing the gazelle at the end. And then over here for the gazelle, we have the beginning. At the same time, the lion is running towards the gazelle. The gazelle does not notice. And then the gazelle notices and then accelerates towards and then past the lion. And then over here with the lion, it sees the gazelle running towards it, slows down, turns around. And the gazelle running at a constant speed, which the lion and the gazelle at the end are running at the constant speeds. We can see the lion is running much slower than the gazelle. And that's the physics problem 17. Hope you enjoyed.